In this question, instead of vectors, we have 2 points. Each of these points have 3 dimensions: x coordinate, y coordinate, and the z coordinate. So the rule for finding the length of a line or a vector is, if you have coordinates x1, y1, z1 and x2, y2, z2, then the length of the line would be AB square root difference of x whole squared plus difference of y whole squared plus difference of z or z whole squared. That's it. And the square root would be above the entire thing. Now, when you find vectors, in case of vector, it would be the vector AB OB minus OA. And OB is, if I write in the column vector format, the x coordinate would be here, x2, y2, z2 minus the position vector of A would be x1, y1, z1. That simply means AB would be x2 minus x1, y2 minus y1, and z2 minus z1. In question number A, this particular question is asking for find the modulus of the vector. Now, if you have a vector AB in the format of xi plus yj plus zk, which can be written as column vector format x, y, z, then the modulus of that vector would be square root coefficient of I whole squared, coefficient of j whole squared, and coefficient of k whole squared. That's it. Now, in question number A, we have to find the modulus of the vector AB. That means the length of the line AB. Remember, modulus of a vector is the same as length of that line. So we can simply write AB equals to square root. So the difference is going to be, remember, this one is A, this one is B. So we can write difference of x 3t minus 2t whole squared, difference of y 2t minus 10 whole squared, difference of z 5 minus 1 whole squared. So this turns out to be 3t minus 2t is t, so t squared plus 2t minus 10 is a minus b whole squared, so this is going to be a squared. So 2t squared is going to be 4t squared minus 2ab, 2 to the 4, 4 tens of 40, so 40t plus b squared is going to be 100 plus 5 minus 1 is 4, 4 squared is 16. If we further simplify, this is going to be t squared plus 4t squared is 5t squared minus 40t. 100 plus 16 is 116. So this is how we can directly do it. If you want to do it in another way, you can do it in this way. We can find the vector first. The vector AB equals to OB minus OA. So this is alternate method. Okay. So what's going to happen over here is the vector, position vector OB is 3t, 2t, 5 minus the position vector of OA is 2t, 10, 1. And when we subtract this, so this is going to be 3t minus 2t is t, 2t minus 10 is 2t minus 10, and 5 minus 1 is 4. So modulus of that is going to be, so t squared plus 2t minus 10 plus 4 squared. You can do the sum in either way, it doesn't really matter. Now take a look at question number B. Question number B is completely different. It does not deal with vectors, it really deals with coordinate geometry. It deals with maxima and minima. So what they are saying is that by differentiating the length of AB squared, find the minimum value of t. When you have a question like that, what you do is, let me write question number B. L squared equals to 5t squared minus 40t plus 116. So now we can consider the entire length of the line. We can consider it L, and if you remove the square root as they suggested, it becomes L square. So this is a parabola. It's a Cartesian picture. It's a parabola like this, and we have to find the minimum value, meaning the turning point. So this particular question is completely differential calculus and coordinate geometry, and you have to think of this as a different question altogether. So what we have to do here is we can write the derivative. So at the turning, or let me write minimum point or minima. At the minima, derivative or gradient or rate is 0. Therefore, if we differentiate this, it turns to be 5 to the 10, 10t minus 40, this is 0, equals to 0. So this is the derivative. This is the derivative what we are finding. And from the derivative, we can find the value of t. So the value of t turns out to be 40 divided by 10 equals to 4. Now, how do you know this is the minima? Although they did not mention that you have to check, it's a good idea to show how do you find that. That's the second derivative. So you write the second derivative. So the second derivative, the first derivative is this. 10t minus 40. Let me write it down over here. If think of this as a curve. If 5 t square was a curve, so let me write 5x squared minus 40x plus 116. I'm writing in the Cartesian form of x and y. So you found dy by dx, and dy by dx was 10x minus 40. Now you have to find the second derivative, d2y by dx squared, which would be simply 10. So that means second derivative, since uh, second derivative is positive, meaning greater than 0, it is minimum, meaning t equals to 4 will give you the minimum value. That's it. And the next question is usually finding the length. So find the minimum value of this L, AB. So what we do over here, when t equals to 4, then L square equals to 5, 4 square, putting it over here, minus 40 into 4 plus 116, and this turns out to be, so 16 5s 80 minus 40 into 4 is 160 plus 116, and that is 36. So this is the minimum value of L square, but the question was find the minimum length. Hence, minimum value is, it should be square root of 36, which is 6.